Methods for Modeling Functional Clinical Data by Ruben Pereira and Hassan Kim, undergraduate students from the University of Toronto. In this project, we model the effects of post-Norwood blood pressure and cardiovascular output on the mortality of hypoplastic left heart syndrome neonates using functional methods. Hypoplastic left heart syndrome is a condition where the left heart ventricle is underdeveloped or absent. Upon detection, the neonate undergoes the Norwood procedure. Our data, blood pressure, cardiovascular output, and heart rate are collected within 72 hours post-Norwood. Previous research says that maximizing blood pressure and cardiovascular output are important predictors of early post-Norwood mortality individually, but disregard the importance of each other. But we believe that both cardiovascular output and blood pressure are important in predicting post-Norwood mortality of HLHS neonates. What is functional data? Functional data is multivariate data with an ordering on dimension. The key assumption with functional data is smoothness. It's measured over a continuum. The data for each individual is collected over time. However, within the individuals, the observations are correlated. Therefore, the parameters would be inconsistent. Ignoring the correlation in the observations and using independent data regression techniques would lead to inconsistent parameters. The parameter estimates may be biased, the mean parameters may be inefficiently estimated, and the inference test may be incorrect. So we should consider using functional regression techniques. For our procedure, we will smooth the data recorded from all the patients. We will then use principal component analysis to generate an estimate of the explanatory variable. Then we will perform penalized functional regression. Smoothing the data. Kernel smoother. A statistical technique for estimating a real valued function by using its noisy observations, when no parametric function for this function is known. We will use this technique to generate a smooth function for the covariates, blood pressure, and cardiovascular output. Here's an example of kernel smoothing of mean blood pressure measurements over time. Functional principal component analysis. Principal component analysis is a statistical procedure that uses orthogonal transformation to convert a set of observations of possibly correlated variables into a set of values of linearly uncorrelated variables called principal components. We use functional principal component analysis to generate a basis of size k principal components that explain a significant proportion of the variation. Then approximate the covariates by a linear combination of the principal components and calculate the appropriate coefficients. We can see that the functional covariate can be expressed as a linear combination of the eigenfunctions. From the right-hand plot, we can see how we can generate a smooth functional predictor from all of the observations of all of the individuals of mean blood pressure over time. We now perform penalized functional regression. We use logistic regression for a regression model. From the derivation, we can see that the predictors are now independent and therefore uncorrelated. We see that the predictors are now independent. Therefore, we can use linear models to calculate their coefficients. In this study, we worked extensively with Anne Shao, Professor Alison Gibbs, and Edwin Lay. We used these references as research for this project. Thank you for watching our presentation, and have a great day.